Hey guys, it's Adams here. Sorry, my son is sick unexpectedly, and so I have to be out again. I definitely wanted to get this lesson started for you, so hopefully this video will help you, and you guys will be able to complete your work today and be good, and then have a wonderful weekend. So far we've talked about ways of describing a distribution using shape, your symmetrical, skewed left, skewed right, and then we talked about measures of center, your mean and your median. And today we're going to start talking about measures of spread. We're going to just start an introduction into the first measure of spread, standard deviation. We'll get more into it next lesson. But I just kind of want to explain what standard deviation is and how to find it and all that good stuff. So here we go. So follow along on your paper. Looks just like mine. Okay, so the standard deviation is used to tell how far on average, ready, a data item, that's what goes in those three spaces right here. So a data item is from the mean. The smaller the standard deviation, the closer the scores are on average to the mean. When the standard deviation is large, the scores are more widely spread. All right. So basically, again, standard deviation is a measure of spread. We're talking about how far away are these data from the average. So if I have a small standard deviation, it means that the spread isn't very big and everything's kind of around the average. If I have a big standard deviation, it's all spread out all over the place. Okay. It says steps for calculating the standard deviation, and we're going to put it into words. I don't want to do that. Let's just skip right into actually calculating it using the numbers. But let me explain a little bit more first. So standard deviation is used when we have a symmetrical distribution. So we've seen these before. It's generally when they're perfectly symmetrical or fairly symmetrical, we call it. We call it a normal distribution when it is perfectly symmetrical, and it follows some certain rules and patterns. So the mean is always in the center of the distribution. If you look on your paper, you have this. Oh, and I already gave you the percentages. All right, so basically your mean, your X bar, is right in the middle here, okay? And then we are one standard deviation above the mean, two standard deviations above the mean, so they're positive, three standard deviations above the mean. And then when we're below average, when we did worse than the average score, you could say on a test, this is one standard deviation below the mean, two standard deviations below the mean, and three standard deviations below the mean. So when you have a normal distribution like this, it always follows these same percentages. So your paper is broken down into these little sections that I gave you. I want you to write in these percentages. So this one is always 34%, this one's always 13.5%, this one's always 2.35%. And since it's symmetrical, it's the same on this side, just going the other way. Okay, so take a minute, pause the video, do what you gotta do, and go ahead and label those percentages. I'm going to mess with this for a second. Okay, so now that I have these two 34 percentages here, basically, if I take the mean and I go out one this way and one this way, well, I'm just adding it up. So that would be 68%. So I'm going to put that here. This is my 68%. Now, if I include these 13.5s, I'm going out two standard deviations away from the mean on both sides, then that's all going to add up to 95%. So I'm going to make that a 95%. Okay, so 95% of my data falls within two standard deviations from the mean. Okay, this is where the majority of my data is. It's around average. Things start to get a little rarer. They don't happen as much when they go out this way towards the end and this way towards the end. These are very rare values. This is where most of the data falls. Okay, let me change these colors real fast. Okay, once I add in that 2.35%, and I add them all together, so 3 standard deviations about the mean, so I go 3 standard deviations this way, 3 standard deviations this way, it all adds up to 99.7%. So almost 100%. It's not 100% because even though these look like they touch and close the curve, they're an asymptote. They actually never touch that line. They just keep on going forever. It's just a really, really small percentage. Okay, so now you should have these notes on your paper. If you don't, please put them on your paper. Okay, and we'll get into this. We're going to use this a little bit today, but we're going to get more into this into topic 12, and we're starting topic 9. All right, let's keep going. So we basically said the further away from the mean, the less often the data will occur. Okay, so the further away from the center, the less often the data will occur. So over here is very rare, over here is very rare. This happens often. Okay, I need to zoom in on that. Give me 1 second. Oh, wow, that's a little too much. Let's try that again. Sorry, it's my first time ever doing this. It should be kind of fun. Let's see. A little less. Okay. All right. So guys, the first thing I want you to do is to take these numbers. This is just an example. I gave you test scores. Okay. We'll pretend these are test scores. Go ahead and find the mean. I will do the same. And how many do I have here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So guys, remember, n is my sample size. So that is going to be 10. So my mean is going to be 63.1. Oh, no, it's not because I have to add that 22. 29, I missed the 29. All right, sorry guys, I missed that 29 when I calculated my mean. I didn't put it in a list and I missed the 29, so it should be 66. So your mean is 66, your n or your sample size is 10. So each one of these is an x of I, an individual data point. Okay, so what we're going to do is we're going to take each of these and we're going to put them right here. I want to change my color because I think the green is a little light. Let's go to blue. Okay. So I'm just going to put 22, 9, 22, and 29. Okay, so I know it's not that pretty, but I have all my numbers here, okay? So that's what goes here. This is my x. So if I look, this is my actual standard deviation formula, and this is what we're completing. Okay, we're completing this whole entire formula in step by step. So first we have all of our data points, and then we want to find the difference from the mean. So for example, my first one was 22. So I have to do 22 minus my mean, 66. Okay, so 22 minus 66 is a negative 44. So I'm going to do that for every single one. So for example, this is going to be 99 minus 66. Okay, so it's going to be 33. Okay, so I want you guys to do that for every one of these. So if you need to, pause the video, come back, and we'll fill it in. Okay, so I filled in my column. So that's what I want you guys to do. It should look the same. Check your work with mine. Okay, so that's the difference from the mean. So now we have completed this tiny little step right here in these parentheses. Okay, the next thing we need to do is we need to square all of these values. So one thing I want to tell you, be very careful when you're squaring these when using the calculator, because if I put negative 44 in the calculator and square it, so negative 44 squared, I get negative 1,936. But here's the thing. Squaring is just multiplying the number by itself, right? So I'm basically doing negative 44 times negative 44, right? What's a negative times a negative? Wait a minute, it's a positive. How come I'm getting a negative here? Well, the calculator is doing some really weird thing where it's putting the 44 in a parenthesis with a negative 1 on the outside, so it's squaring it and then multiplying it by a negative 1. Don't ask me, I know it's weird, but just this is what you need to do. You either need to know that whenever you square a number, it has to be positive, or put it in parentheses. Negative 44 squared, enter, and then you get the positive 1,936. So that's what's going to go here, 1,936. Okay, go ahead and square all these values, and we'll be back in a minute. So go ahead, pause the video, square all the values, and we'll meet up in a second. Okay guys, so now we have completed this part of the formula, this top piece right here, just this parenthesis, and then squared it. So the next piece is we need to find, remember this guy, it's a capital sigma, and it means sum of or total. Okay, so we need to find the total of that, which means we need to add up everything in this column and put that number right here. So take a second, go ahead and do that, pause the video. Okay, so you should have gotten 8,338. Okay, so that is the total. That's what goes right there. That is this whole top portion of this guy right here. So it is this right here. Okay, so I am just going to replace that with 8,338, and then we divide it. Let's see if I can do this on my screen at home. This is going to be lots of fun. All right, so I'm going to divide this by my n minus 1. Well, my n was what? It was 10, right? So minus 1, that's easy, that's 9. Okay, so then I'm going to go ahead and put that in my calculator. And I get here we go. This is equal to 926.444444444, right? So we'll just call it 44. We're repeating. Okay, this is called my variance. We don't really do a whole lot with the variance. We actually don't really do anything with it in this class. But the variance, the whole purpose of the variance is if you square this number, because now we've done everything on the inside of this radical. So if we square this number, we get our standard deviation. So our standard deviation is equal to, let me just draw this out here. Okay, my standard deviation is just now equal to the square root of 926.44. Okay, does not look pretty on here. I apologize, but it's what I can use today. All right, so I take the square root of this number. So, you know what, let me show you in this calculator. So I take square root, so second square button, so see it right here, second, okay, so second square root, and then I get 926.44. All right, so that's 30.437 or 30.44. Oh, let me go back to my screen here. 30.44. And yay, I have my standard deviation. Wasn't that fun? And that was just for 10 numbers. So next subplan, I'll make sure I give you like 200 numbers, right? No. Okay, so this is a huge pain, right? We don't want to do this over and over again every single time we have to calculate standard deviation. A lot of you were fighting me about the lists and, oh, do I really have to find the mean and median by putting it in a list? Can't I just do it by hand? Sure, but then you're going to have to do this by hand too, and you don't want to. So what we're going to do now, I'm going to show you how to cheat and use the calculator. It's not cheat, it's called being resourceful, but here we go. Okay, so stat, enter. We know how to do this. We know how to get to our lists. My lists are looking pretty crazy right now. I'll clear it out. And then I'm going to go ahead and enter these numbers into my list one. Don't know why that didn't just enter. All right, I'm going to pause it. You guys go ahead and do the same thing. I'll meet back with you in a second. Okay, I've got all my numbers in now. So I've got all my numbers in my list one. So I'm going to go to stat, calc, same way I get my mean and my median. I'm going to hit enter and I'm in list one, so I can just hit enter. I'm good to go. Oh, look, there's my mean. And oh, look, N, 10. My sample size is 10. Okay, if I wanted to get my median, I could scroll down here. I get my median. I scroll back up. So my standard deviation is this S of X. Now, this is also standard deviation, but we're not going to be using this for a little while. This is of a population. We don't normally have population data. We have a sample. So we're going to be using this S of X. So S of X is equal to, oh, look, 30.437. Isn't that what we just calculated? Yes, it is. Yay, yes. Okay, so now it's easier. I don't ever want you doing it by hand again. I won't ask you to do it by hand again. Now that you know where it comes from and what it means, now you can just use the calculator. And you can go ahead and use your notes to calculate standard deviation and to find the percentages using this guy right here and answer the questions in your packet. Okay, please hand it into the yellow bin when you're done. Be respectful to the sub. Please show them that we are McCain and do a good job. And I will see you. Oh goodness, I will not see you until next week, and we have a few days off next week. So enjoy your nice long weekend. If you have any questions, shoot me an email. Grades are pretty much done for the marking period, so reach out to me if you have any questions. Okay, bye guys.